In this video, we're gonna learn how to recreate wireframe from CAD data. We're gonna use a moment of inspiration to create the mesh, and then we're gonna build a little process in Houdini to recreate a wireframe around all the patches, and also create a true real geometry for the wireframe, so you can render it in any render engine of your choice. So that's the model we're gonna work with. Let's export this as polygonal mesh. We're gonna use OPG format. So the first parameter to tweak is probably the angle, which is driving the smoothness and resolution of the mesh. With an angle of 3, we're gonna already get a lot of polygon in a small area like this. So it's a good idea to combine this with this parameter, avoid smaller than. That can help to reduce polygon count in this kind of area. Probably that's a bit too low, too high. That's fine. And finally, maybe we can add a little bit more resolution here without changing the angle. Just use the divide larger than to add a little bit more resolution. That's already much better. Because we are using OBG to transfer the data, it's better to use a quad and triangle or triangle only. Doesn't really matter. And very important is to uncheck the weld vertices along edges, because it's this option that will help us to recreate the wireframe in Houdini. And we can also try to export the curves only, just to try something in Houdini, like just selecting the edges, Ctrl C, and Ctrl V. We can export them as polylines using the DXF format. Export type, yeah, 3D curve, polylines, and angle of 3 should be fine. It's just another way to create the wireframe in Houdini. Doesn't work very well, but well. So let's continue the process in Houdini now. So here is the moment of inspiration mesh. Obviously, we should rescale it something like way smaller. Yeah, looks probably better. And yeah, we can try to load the DXF file with the curves, the polyline, and also, yeah, we probably have to rotate them to match the both models, like voila, so they're both overlapping. Yeah, looks like for some reason I have planar polygon from these curves. I don't know exactly why, but you can delete them with the AND operator on a wall, and that will just leave the curves. And we can create a poly wire, so basically creating tubes around these curves. reducing the scaling. For the moment, I will also disable the smoothing just to speed up the process a little bit. So yeah, voila. Here we've got the curves. Maybe we can make them a little bit bigger. So this is pretty easy to create, of course, but if we merge the two models together, I will also add color to help the visualization. Merge the two models, and yeah, probably I should add normals to this thing. Point normal. Voilà. Because they are not using the same kind of meshing system, there are a lot of trouble. Like they do not follow exactly the polygons topology, and at some point you see here, for example, they even disappear below the model. I'm pretty sure that if the polywire is a little bit smaller, you will get some artifacts, I mean disappearing edges. And yeah, you look at this, for example, yeah, here you can see that they completely dissolve below the models. So yeah, it's a way to create these curves, but probably not the best way to do it. We're gonna find another solution for that. So I can just delete all these things and we start with this mesh. So as I said previously, what we're gonna do is to extract every poly island, because we didn't weld the edges when exporting the models. If I select, yeah, so you have to click on this small icon here and select 3D connectivity, and then you can see all the patches, in fact. And the idea is to extract them one by one and create a polyline around them. So that way we can recreate a wireframe that perfectly match the polygonal model created here. So let's start this thing. We can first, I like to clean unused data, so like maybe if there are groups on the model, just deleting any groups because I don't need them. And same for the attributes. There are probably a couple of attributes that we don't need for this process. Path name, material shops, we don't need UVs, so yeah, deleting all these attributes, yeah, it's maybe a good idea to start with. So we're gonna process every island one by one in a loop node, so it's for each loop. By default, this operator, we are looking for a name attribute, and based on this name they will process the piece one by one. So we need to create this attribute, and we're gonna use a connectivity operator for this. So every connected piece of geometry we receive a name ID. We work on primitives, and we're gonna call the attribute name because that's exactly the name attribute the for each loop is looking for. We can also use an assemble for that work. It's the same, except that the assembler already create a name attribute based on connected pieces. Both will work, of course. We're gonna use the connectivity one. So yeah, there are actually 8,320 pieces, and we can look them one by one using the single pass. Like that's a piece 1, 2, 3, 4, 5, etc. Let's look, for example, I don't know. Voilà, that's the piece 50. So we can work on this piece first, see how we extract the edge lines. We can do that first by creating a group, an edge group. We are working obviously on edges, and there is a function in the edges included by edges. We can check the unshared edges. That will give the boundary edge selection. Maybe it's not very visible, but yeah, we've got a group now. We can rename that, I don't know, edges. And to extract them, we can use a polycut. We are working on edges. We can look for the edge group name, and yeah, we need the inverted group. So we can use an exclamation mark, and that will just invert the edge selection. And we can uncheck the keep polygons closed, and now we've got a nice boundary edges, polylines. In fact, if we apply this thing on the whole model, letting it cook, and voila. So we have already the poly wire we created, and there are a few programs. The first one, yeah, it's not very obvious, but in this area you see all these edges here, and there is something a bit fishy with poles. I'm gonna try to isolate this piece. I will blast at it and invert it and reprocess this thing. So here we have a better look. So yeah, for some reason poles are not merged when we exported the mesh with Moa. I mean, it's obviously we didn't want to weld the point, but there is something strange around the poles here. We need to find a way to merge these 2 points, at least to all the edges around these 2 points. So for that we're gonna use first we're gonna fuse everything together, every point. So now they are unwelded, but with the fuse node you can actually fuse point together. I've reduced a bit the distance, and so now all the points are merged, and we're gonna try to find a way to isolate the poles. So poles, at least this kind of poles here, where we have a lot of edges coming through. To do that, we're gonna create an attribute on this point that we're gonna call valency or degree. It's the same concept. It's just computing how many edges are coming to every specific point. So to do that, we can use an attribute wrangler, and we process them on point. That's fine. We're gonna create a new attribute. Yeah, it's an integer. We're gonna call it val, and we're gonna use a vex function called neighborhood count, which is exactly what we are looking for. The input is okay, which on which input are we working on? Obviously the 0, and we're gonna process that on every points. So pt So now if you look into the spreadsheet, you've got a new attribute for every point, and yeah, these 2 points with 127 connection, that's all the 2 poles. So thing is that we don't want to work on the merge version. We just want to merge these 2 points together from the base model. So we can use an attribute transfer. Yeah, I think I've attribute transfer. Okay, so we can transfer the attribute from this mesh on this one, and we only need on the valency, and in the condition you can disable the distance, because we don't need any threshold in the distance. So now we are using the unwelded mesh, and as you can see we have now a bunch of points with the same valency. That's all the triangles coming to this point here. So we can fuse but first we have to group all these points together, so we can fuse only based on group. So with the group selected, oh sorry, it's we're gonna use a group expression, group by expression. We're gonna call it pole, doesn't really matter, it's processing on points, and we're gonna create an expression like something like we're gonna group every valency greater than 8 should do the trick. So voilà, so that's all the points we're gonna merge. So with the fuse we can choose to only fuse the pole groups, and I've changed the timeline, and voilà, that should fix. Voilà, now we have only the edges and not all these small edges in a polycut, and that's fine. We can process that to the whole model. Yeah, I have to disable the blast we previously created. So again, all the model is processed. Voila. And one last thing, it's not very easy to see, but for some reason the polycut still left some polygons behind in some area. I don't know, voila, we got it. So you see here, I've got still some polygon. I can try to select them. Yeah, you see. So to remove this last polygon, we can use an AND operator, and we gonna process them. We're gonna just choose unwall on a close U, and that will, it's one way to remove all the polygons and keep the lines. Or you can also use a carve operator for that, doesn't matter. So voilà, the small edges the small triangle we have here are deleted. So that's mostly it. Of course, because we have processed patches one by one, we have a lot of overlapping edges and of course overlapping points. So we need to merge that together again. First we're gonna merge all the points, like again a very small radius with the fuse operator. So we switch from 300,000 point to 169,000 points, so that's already good. And now we have to care about the overlapping edges. It's not so easy to see, but there are lots of overlapping edges, and for that we can use the clean operator. We don't have to remove the generated. I don't think we have any trouble with that, but you can fix overlaps. So if you click on fix overlaps, actually it will delete it every pairs of edges. So obviously we don't want to remove them, we just want to collapse them, and voila. So now again we switch from 300,000 primitives to 200,000 primitives, much lighter of course. So again we can make a little bit of cleaning because we have attributes and groups we don't need anymore. So group delete, can just delete anything, any groups, and you can add an attribute delete. I don't know what I have typed. Attribute delete. Here we go. we don't need names, attribute, and the Valencia attribute is not needed anymore either. So we can now actually already start to save this polylines model as it is, so we can use a rope alembic output. I'm gonna call it that wire polylines, for example, .abc. We can render it to the disk, and I'm gonna also again create a polywire. I don't remember, I think it was 0.02 was pretty fine. Again, I will reduce for the moment the smoothing and the joint scale, and I don't need a vertex texture on this thing. So now we have two polygonal tubes around the curve. That's very nice. We need to add normals to this on point. That's good. And maybe we can maybe have 6 division. 4 division should be enough, but that's very, very nice polywire. And now if we check that, so I will add a color so it's more obvious, and we merge these two mesh together, the wire and the input. You can pick it somewhere from here. Comparing to the previous version we had, it perfectly matched, of course, the polygonal model. So the only thing we have to fix probably is, you see all these small edges are disconnected, and that's the polywire. The smooth point should fix that. And I'm not really sure what the joint scaling is doing, but it looks like it can help to smooth some connection because it creates also real connection between every wire. It's pretty cool. So voila, we've got the mesh. This one we can also save, so I don't need all these things. I will just create another Alembic exporter for this thing, and I will call it wire, something like wire mesh, render to the disk. We can maybe make it a little bit bigger. So render this thing to the disk, and I will also just render the mesh itself. So because I know that everything is aligned now with the same scaling, we can start from this area, and this is the render mesh.abc. We can render it to the disk. So the data is ready. We can now import that in Modo and do some rendering. So while we are in Modo here, Modo 501, I will first import the wire polylines because it works very well in Modo. It's probably much lighter in the viewport, and Modo has an option to render curves, and it works with that kind of data. I will, where is this mesh? Okay. I will assign a material like wire, and activate the render curves, and I don't know, using something like 2 millimeter. I don't know which option is the fastest. I mean, using curves as polygon. Yeah, we're gonna try with that option. If I do a preview, so you see you've got now the wireframe with global illumination. It's very nice. Maybe I should disable the Iranians thing, so there are already a lot of polygons here. So that's alone, it's already it's a nice object, right? And we can also, of course, import the mesh itself, the render mesh. Render mesh. I'm not really sure why there are so many subfiles here. I think that's the mesh. Yeah, so I will call this one ghost. And the kind of rendering I like to do here is I will global illumination. I will activate the indirect effect SSS. I don't need any light. I don't need any environment light object. And let's see what's happening. So nothing, of course. I mean, everything should be black. I will first just add a bit of illumination in the wireframe. So now it's the wireframe that are doing the lighting, and that gives some very nice effect already. And for the mesh itself, yeah, we can activate the conserve energy, maybe adding a bit of reflection. Not too much roughness, just to have a little bit of reflection. Can make. So we have now reflection of the wireframe in the model, and I also like to use the SSS. Can make a bit of bluish, and not too much depth, but yeah, that's mostly it. For the previous example, I was also adding a bit of transparency, but to see the line behind, and playing with the absorption, of course. So it's something like this. It takes a little bit of time to render, of course, and I will let this one rendering a little bit longer. So after a few minutes you should get something like this. I've just changed a bit the subsurface amount, going a bit crazy here, but yeah, you get the idea. And the cool thing is that you can probably do that in any render engine, because instead of using the polywire, you can just use the polymesh creating in Houdini. I hope you enjoyed the video, and see you.